Hi, everybody. We're going to continue talking about the measures of central tendency. Today, we're going to talk about the median. So, quick recap, the mean is the arithmetic average of a data set. In other words, we add up all of the data, take that sum, and divide it by the total number of observations of the variable that we had. It's usually appropriate, especially if you have symmetrical distributions or relatively symmetrical distributions, because what occurs there is all of the values that are on the right of the mean are balanced out by all of the values that are on the left of the mean. And so when it's a symmetrical distribution, that is perfect. That's exactly what should happen. Now we run into problems when we have non-symmetrical distributions. So take a look at this. Let's imagine that I sampled maybe 10,000 people in the United States and I just said, hey, how many cars do you own? There's a bunch of adults, right? I might get something like this. Now, I don't know what the real data would look like, but let's imagine it looks something like this. Some people have 0 cars, right? So you would see it starts maybe around 0. You'd have a lot of people saying, yeah, I don't own a car, right? Then a lot of people have 1 car. They own 1 car and that's all. And then some people have 2 cars and maybe that's it, right? Or maybe they co-own the cars. Like for example, between my wife and me, we both own both of our cars, right? So it might be something like that. But again, I'm just sort of making this up. And then some people do have 3 cars. I've got a neighbor who owns actually 4 cars, and it's just him and his wife, right? And then on and on, you've got something like that. And some people are car collectors. They have 10 cars. Not very many, but some people do that. They own 10 cars or they have a junkyard or something. And so it would go on and on and on, right? And in theory, you've got people like Jay Leno who owns, I don't know, owns 40 cars or something like that, right? So you'll often find these skewed distributions again when there's sort of a lower limit, in this case 0, and it just can't go, right? I can't own negative numbers of cars, really, not really. And then it can go up though, and it's not unusual for it to go up from there, but most people kind of lean towards just a few, right? So with this skewed distribution, we have a problem with the mean. First of all, the mean takes into account all of these people with lots of cars, and then it stretches the mean towards that positive side of the distribution because it says, well, look, this person owns 10 cars, and they are balanced out by 10 people who own 1 car. Okay, so the balance then shifts towards the right in a skewed distribution, a positively skewed distribution. If it were a negatively skewed distribution, it would shift towards the left. And so that is the inherent problem using the mean. The mean is biased by extreme scores. It's biased by outliers, and therefore asymmetrical distributions cause the mean to not well represent the data. Okay, so then what can we use instead? Well, one measure of central tendency that we can use when the mean isn't probably appropriate, specifically for skewed distributions, is called the median. We simply take the middle value of the data set and say that is our best representative of the data. Okay, so by definition, the median is the value where half of the data are above that value and half of the data of the data set are below that value. And that's the definition. So therefore, it's very easy to find, and I'll show you how to do that really quickly. So let's imagine that I do a survey and I ask people, how many dates did you go on in the last month? And this is just from 7 people, and let's make sure that they didn't go with each other, right? That would complicate things. But so we'll say I sample people. How many dates did you go on in a month? I asked 7 people, and they each gave me this information, right? So now I need to find the median for this information. The very first thing you do is you sort the data from the lowest value to the highest value. This is a very common mistake that people make, is they don't do this. They just find the middle value in the table, for example, but you have to sort it from lowest to highest first. Suppose you could also do highest from lowest. It doesn't actually matter. It's not going to make a difference, but let's just get into the habit of going lowest to highest. So in other words, these were the data they gave me, right? They said this person went on 2 dates in the last month, this person went on 0, this person went on 4, and so on. And so I need to rank those from the lowest to the highest. So 0 is first, goes there, 1 is accounted for right there, then there's a 2, and so on, 3, 4, 5, and then a 7. So there was no 6 in that particular data set, and that's fine. So now I've got the data set ranked from order of lowest to highest. The next step is to simply find the middle of the data set, and that's of course very easy. You take the data set and then you say which of those values is right in the middle, and of course number 3. 3 is the middle value because there are 3 values below 3. There are also 3 values above 3. Okay, therefore 3 is the middle value. Now, of course, because there were 7 digits here, 1, 2, 3, 4, 5, 6, 7, it's an odd number, so I know there had to be an actual middle number. Okay, so there you go. That's how you find the median for this particular data set. The median would be 3, the median value or middle value. Now, in some specific cases, you can't actually come up with a middle value. So let me show you an example of that and then what to do. So let's imagine I had this data set. It doesn't matter what it is for now, whatever the variable would be. But right, as you can see here, we have 6 values, which means that there is no middle value inherent in the data set, unless they were the same value. Sometimes that happens if, for example, if both of these values, 27 and 27, then that's fine. There's nothing really to do. You know that it's 27 is the middle value. But in this case, we don't have one. So what we do here is we take the arithmetic average of those 2 middle values, okay, those 2 that are right in the middle. We need to find out what value would be right in between them, and the way to do that is to take the mean of the 2 middle values. So that's of course very simple. If you don't recall how to do that, look at the last lecture where we talked about how to take the median. So in this case, we get the average of 27 and 31, which is 27 plus 31. We divide by 2 because we're spreading that out over just those 2 values. And of course, we find 27 plus 31 is 58. 58 divided by 2 is 29, and so therefore the median for this data set is 29. Now that may confuse you. It may throw you off because you say, but how could 29 be the median of a data set where there is no 29? And that's fine. It's the definition of the median because the value of 29 has exactly half of the values of the data set above it and half of the values of the data set below it. So therefore, by definition, it is the median. Okay. Okay, and so that's just what we'll talk about today. When there are skewed distributions, the mean is probably not appropriate for that. Like if you think about that with the cars, if you were to say, hey, what's the average number of cars that adults in America own? If I told you it's 5, which is what it sort of looked like in the data set, you'd go, oh, wow, people on average own a lot of cars. So does that mean if I were to just walk down the street and ask an adult how many cars they own, my best guess would be 5? And that, of course, doesn't match reality very well, right? In fact, it's much more likely they would be closer to maybe 2 or 1 or maybe even 0, right? And so the mean is probably not a good representative when there's a skewed data set. Instead, the median is probably more appropriate. And so that's why we often use the median for things like income in the United States, because income is definitely positively skewed. And in fact, in most countries it is, and in every country I'm aware of, it is. And so on like that. So the median is often appropriate for skewed distributions. There's, of course, one more measure of central tendency that we haven't talked about. It is called the mode, but we will talk about that next time. Thank you very much for your time, and I'll see you then.